Student, I am Hydrostatics Chakraborty, lecturer in electrical engineering of C. Ramakrishna Institute of Science and Technology. Today I am going to discuss about the part 2 lecture of the hydrostatics and pumps of elements of mechanical engineering. So the first slide is the pressure measuring instrument. So there are several types of instruments which are used to measure the pressure. These are barometer, piezometer or pressure tube, manometer, the Bourdon gauge, the diaphragm pressure gauge, and the micromanometer or U-tube with endless end. So these six are the names of the pressure measuring device. In our today's lecture, we are going to discuss about the different types of barometer. The first one is the barometer. So here you can see the image or the diagram of a barometer. This is a barometer. This is a bowl which is filled with mercury, and this is a glass tube. This is also filled with mercury. So the barometer is a device meant for measuring the local atmospheric pressure. You can see here the figure. So local atmospheric pressure means this pressure is atmospheric pressure is depends upon the height or the height of the altitude. So when the height is increased, then atmospheric pressure is reduced. So the local atmospheric pressure means the pressure at a certain height. So here it is consist of a 1 meter long glass tube closed at one end and completely filled with mercury. That is the glass tube closed at one end. This is the closed and completely filled with the mercury and kept inverted in a boil of mercury. This is the boil of mercury and it is kept inverted in it. Thus, and a small quantity of mercury will drop into the boil and thus a vacuum forms in the upper end of the tube. So when this is dropped into the bowl, so there is a vacuum is produced in the upper end of the tube. The atmospheric pressure acting on the surface of the mercury in the bowl will support a mercury column in the tube. So this is the mercury column. Okay. Now let H be the height of the mercury. That is the height of the mercury column in the tube measured above the surface of mercury in the bowl. So that is the construction and working principle of the barometer. Now let PA of the atmospheric pressure intensity. So let PA be the atmospheric pressure intensity, and the height of the mercury column at sea level is approximately, that is, we know that 76 centimeter, that means 760 millimeter of mercury. Then from this equation we can see that PA equals to Wm into H, and Wm is the specific weight of the mercury. So that is the constant, the specific weight. So or H equals to PA by Wm. So that is atmospheric pressure head in terms of mercury head. Okay. So by this equation we can measure the height or the atmospheric pressure head in terms of the mercury head. And this atmospheric pressure head at sea level, we have already discussed that 760 mm of mercury. The space above the mercury in the tube will contains the vapor of mercury. This space is called torricellium vacuum. So the vacuum which is produced in the upper section of the tube, that is known as torricellium vacuum. And the mercury is ideally suited for use in a barometer due to its high density and its very low vapor pressure. Okay, it has a high density, so the volume is very small or volume is very low in case of mercury. The altitude of a place and weather condition influence the reading of the barometer, which I have already told that according to the altitude the atmospheric pressure is changed. When the altitude is high, then the atmospheric pressure is low because the volume of the atmosphere or atmosphere air is increased. A reading of a barometer recorded at a spot indicates only the local atmospheric pressure. The international standard atmospheric pressure is 101.325 kPa according to the 10.325 meter of water or 760 mm of mercury. So that is the standard value of the atmospheric pressure. So now there are mainly two types of barometer. Number one is the aneroid barometer. This device consists of a partially evacuated corrugated box prevented from collapsing by strong spring. Here you can see this box, this partially evacuated corrugated box, and prevented from collapsing by a strong spring. Okay, this is the spring. You can see here, this is spring. Pressure variation cause the front part of the box to deform inward or outward so that the pull of the spring will just resist the force due to the pressure of the atmosphere. And these small displacements are amplified and move a pointer provided over a calibrated scale. So you can see here, you can see the calibrated scale in the downwards direction. There is the calibrated scale, and here is the pointer provided over the calibrated scale, and which measures or which shows the measured value of the atmospheric pressure. So that is the aneroid barometer. Now the next one is the Seafoam Barometer. So here you can see the image of a Seafoam Barometer. This instrument is conventionally used as a household barometer. This is used for domestic purpose mainly. This device consists of a glass tube bent at the lower part to form an U tube. Okay, so this is bent in the lower part and formed an U tube, and the open end of the U tube is enlarged. You can see that the open end of the U tube is enlarged. This enlarged part takes the place of the bowl or reservoir of the ordinary barometer. So here you can see the bowl or reservoir of a ordinary barometer. An iron block of small weight. An iron block, here you can see the small weighty iron block, that is the iron block. This black color thing is the iron block. An iron block of small weight is supported on the mercury surface partly by upthrust of mercury on it and partly by counterweight. So there is the counterweight. So, and this is a pulley by which it can move. And here is a pointer. When this pulley is moved, this pointer is also moved. Okay. The iron block and the counterweight are connected by a string taken over a pulley. Variation of atmospheric pressure brings about rise and fall of the mercury surface in the open end of the U tube. So when the pressure of the atmosphere is increased, then the weight is reduced of the open end of the U tube, that is the bowl. The pressure of the mercury is reduced and the pointer move towards the clockwise direction. Okay. Now, which is turned cause the pulley to rotate by some angle. A pointer attached to the pulley will move over a circular scale from which the atmospheric pressure may be read. And when the atmospheric pressure is reduced, then the marker is upraised, then that is moved towards that. So counterweight pull this pulley and the pointer is moved towards the anti-clockwise direction. So by the help of scale which is connected with the pointer, we can see the pressure of the atmosphere by the Seafoam Barometer. Okay. That's all. Thank you.